In the previous video, we got introduced to the addition reaction of hydrocarbons. Let us learn more about it in this video. For better understanding, we take an example. This is how we can represent a simple addition reaction. There are three major observations that we need to note in this case. Let us begin with the reactant side. First important point to note is that the hydrocarbon that is participating in the addition reaction will always be an unsaturated hydrocarbon. That means it's mandatory to have at least one double or triple bond between the carbon atoms. Addition reactions are not possible with saturated hydrocarbons. This is because in saturated compounds, all the carbon atoms are occupied with hydrogen or other atoms present in the chain. Now let's move on to the product side. The product formed is always a single compound. That means there are no residues formed in addition reaction. Can we notice any byproduct in this reaction? No, we can't. That is how addition reactions are. They always have atoms getting added to the parent chain and leave no residues behind. Lastly, there is nothing removed or replaced in the parent hydrocarbon chain. That means all the atoms that are present in the parent hydrocarbon will be undisturbed, and newer atoms will be added to the chain for giving the new compound. So these 3 points are very important for us to understand and remember the addition reaction of carbon compounds. Now tell me, what do you think will be the use of addition reaction? The use lies in the purpose of the reaction. What does the reaction lead to? It leads to change of the compound, right? That is its major use. Addition reactions are used widely for obtaining new hydrocarbons. To be precise, they are used to obtain saturated hydrocarbons from unsaturated ones. Industrial applications of this reaction lead to the production of alkanes that have great commercial value. For example, margarine that is used widely as a substitute for butter is obtained by this process. That's correct. Unsaturated oils are processed in industries and they are treated with hydrogen in the presence of a catalyst like nickel. As a result, the double or triple bonds break and the carbon atoms become available for forming bonds with the hydrogen atoms. This gives us the corresponding saturated hydrocarbon. The reaction can be represented somewhat like this. What are R1, R2, R3 and R4 by the way? These represent the possible alkyl groups and they could even be hydrogen atoms. Now getting back to the reaction, this is how industries convert the alkenes and alkynes into saturated forms. In other words, unsaturated oils are converted to saturated ones. That's how we obtain useful products like margarine. Although saturated hydrocarbons are not very healthy and are not typically suited for consumption, they are sometimes preferred over many unsaturated products. Their low cost is one of the major reasons for an increase in their commercial value. Well, this was all about the addition reaction. Now let us move ahead and talk about the last reaction from our list. We will look at the substitution reaction of hydrocarbons in the next video.